Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's ContainerJournal.com webinar brought to you by TechStrong and Snyk. My name is Cody J. Brown. I'm the host of TechStrong Learning. We have an exciting panel ahead, but first, I have a few housekeeping notes to cover. First, today's session is being recorded, so if you miss any of our discussion or you'd like to rewatch, a version of the on-demand will be made available shortly after we conclude today's webinar. If you have any questions for our speakers today, we want you to go ahead and direct those to the Q&A tab, which can be found on the right side of your screen. And for any additional comments, or you just want to let us know from where you're tuning in, I want you to direct those comments to the chat tab. Finally, at the conclusion of today's webinar, we will have a drawing for 4 $25 Amazon gift cards, so stick around. So on to the topic of our panel today. We'll be discussing automating security controls across container workloads with Snyk, Docker, and AWS. And I'm joined today by Paul Harland, Solutions Engineering Manager for Snyk, Shai Ruparel, Senior Developer Advocate at Docker, and Amir Javanshir, Principal Partner Solutions Architect at AWS. And it is my pleasure at this point in time to turn the floor over to Paul to get us started. Thank you all so much for being here with us today.
Hi, and thank you for bringing us along, and thank you for listening. Just by way of introductions, I thought we'd just expand on that a little bit. So yeah, I'm Paul Harland. I manage a team of solution architects or solution engineers who help our partners understand our platform and deliver that value to their customers. So today I'll be taking you through the Snyk platform and showing you how it integrates with Docker and AWS in order to look at that whole software development lifecycle and stay secure as you're developing fast. Shai, could you please introduce yourself?
Yeah, hi everyone, I'm Shai. I'm a developer advocate at Docker. I get to build cool, exciting projects and then build tutorials and technical explainers on how they work. I'm really excited that I'm going to get to demo containerizing some applications today and then showcasing how we can find all sorts of vulnerabilities both within the command line and inside Docker Hub. And I guess I'll hand it over to Amir.
Yeah, thank you, Shai. Hi, everyone. I'm Amir Javanshir. I'm a partner solutions architect working at AWS. Partners are really extremely important for us. And my role is to help our partners embrace the cloud and make best use of the well-architected framework we have. And that's it.
Excellent. Thank you very much. Now, today we've got a quite packed agenda. We're going to try to make it as clear and concise as possible. But we're going to go through, first of all, how application development has changed. You know, what we're doing now that we perhaps weren't doing 5 years ago or more, and why this has led to actually having to and needing to integrate security into that developer lifecycle. And by way of examples, we'll show you a live kind of use of the Snyk platform and the Docker platform and show you how to find and fix vulnerabilities as well. And then follow up at the end, let's have a Q&A session. So please add your questions as you go along and we'll either try to answer them at that moment or towards the end as well. Okay, so what has happened over the last 10 years? Well, we've moved from the pre-cloud era to now the cloud era, and that's the paradigm in which we are living. Now, I'm quite an old school developer. When I was developing applications, first of all, we were releasing once a quarter, maybe once a half, and just hot fixes and patches between them. And it was very easy for us to develop in our silo and upon release, send that deployed application out for security testing, out for compliance testing, and get a report back before we go live. Now, as we've moved to this cloud era, we're actually releasing a lot faster. And the developers are doing more and more jobs themselves. No longer do you have to rely on IT and operations to create your infrastructure. You're doing it yourself with containers and infrastructure as code. So you need that immediate feedback as to if you've possibly included some security vulnerabilities, and you need the advice that will really help you fix them in situ rather than at the end of the sprint. And these sprints can be a lot faster with multiple release cycles a day. This is why Snyk has brought to the fore a platform that looks at the whole modern application stack. So if we just go through this stylized stack here, at the top, we've got the code that you write as developers. Now that's your IP, that's what you're working on, that's where your creativity actually goes into your job. And once you're writing that code, you need a tool that can help you identify if you've introduced any vulnerabilities. And that's where Snyk's SAST tool comes in. Now, it really is a next generation SAST tool. We consider it to be a developer companion tool. So it's not something that runs at the end of the day or at the end of the week. It's something that runs throughout the day in the IDEs where you work, up on the SCM tools where you commit your code. Then down below that is the open source that you include. You need to understand the open source that you include. Does it have any vulnerabilities? Is there a better version to use? Actually, is that open source component deprecated? So you need that intelligence that can help you make the right decisions. Again, not at the end of the sprint, but when you're actually making the decisions to use open source. So Snyk can really help you in making those decisions, but also throughout the life cycle of that application, keep them dependencies up to date and vulnerability free. Then we've also got container scanning. So once your application is deployed, you then built with the open source and code, you then deploy that upon a container. You want to make sure that that container doesn't have any vulnerabilities. So again, Snyk can help you with that. We can look at what packages are loaded onto the container, and we can help you decide, should I remove them packages? Should I update them? And at least have the visibility about what's loaded. And then finally, infrastructure as code, a huge area for how we're deploying applications now. Now, using infrastructure as code is very expressive, very wide ranging. You can do a lot of different things, and some of the defaults are not necessarily the most secure. So you need a hand in order to understand when I've made a change or created an IAC script from scratch, have I introduced vulnerabilities? And this is where Snyk can help you. Snyk not just helps you remove the vulnerabilities, but make sure that all your infrastructure as code files fit within the policy designed by your security or compliance team as well. So we really are looking at that whole application stack, and we're helping you identify the opportunities. But one of the real, the real way to explain Snyk's value is it's about empowering developers. If we take the old model where the security team were really the gatekeepers who had to decide whether an application was good enough to go live, what we're trying to do now is actually decentralize or spread the work of that security effort out towards the developers earlier in the life cycle and really empower them with the right information and the right tools to make their own decisions. And where possible, we also want to automate those fixes as well. How can we remove the burden of fixing some of these easy things, making it more scalable and therefore more integrated into the platform? But underneath all of this is the Snyk security expertise. Now, we're not just a vendor who looks at the NVD and the CVE database and give that straight to our customers. We actually have our own security team who find vulnerabilities, who check these vulnerabilities before they get added. We believe that a platform like Snyk is built on the quality of the data in the security database, and that's why we spend so much time on that. Okay, so if we're looking at, again, a stylized DevOps pipeline, this is where all of the tools with Docker, Snyk, AWS really fit into it. So we've got, when you're writing your code, you can start doing the scanning on each of those layers in the IDEs that you fix. In the SCM tools, code commit mentioned here, but there are others as well. We can test, fix, and monitor your applications as well. And then over into code build and even into that production clusters as well, whether it's Lambdas or Kubernetes clusters. So we've got the tools that can really help. And what we're saying is you don't have to integrate everywhere, but you do want to integrate where's best for you. So having that selection of integrations means that you can actually make the right decisions and decide where's best for us to integrate. One of the first places that's really good to integrate is the SCM tool, because that can give you that visibility. So let me show you what a developer sees when they're using the Snyk platform. Oh, I've got a slide to say, there we go. It's a demo from me now. So if I log into the Snyk platform, you'll see that I'm taken to a kind of dashboard here. Now, I'm actually quite a busy developer, so I'm on a lot of different projects. and I can switch context very easily. Now, I'm in the right context here, and I'm looking at my projects. Now, if I've added a repository from GitHub, from Code Commit, from GitLab, all of the different SCMs that we integrate with, it would appear here. And once I've done that scan, you can see that we're giving you a different report for all of those different layers that we mentioned. So here I've got my code analysis. That's the static analysis or SAST scan. We're looking at the code that the developer writes. This is actually a mono repo. So you see there's two package.json, one for the NPM and one for the yarn. So that's a front end and a back end in one actual repo. And it there is giving us some information into the number of vulnerabilities there. Again, we've looked at the Dockerfile, and we've got two infrastructure as code files in this project as well. Now, that's all well and good. We can see there's lots of vulnerabilities here that need addressing. But the important part about Snyk's reports, as you'll see when I go through this, is that we're all about three things. First of all, prioritization. Secondly, remediation. And thirdly, education. These are the three tenets that mean we're not just fixing something now, but we're preventing vulnerabilities in the future. So if I go into this first report, thing unique priority score, that means whatever is at the top is the developer's next best action to fix. And in this case, what we've got here is a hard-coded secret problem. We're given here the information from the code where the vulnerability might have been introduced. It's been assigned to its certain weakness, and I can go in and view the full details. As we go down further, you'll see there's more different types: SQL injection, command injection, allocation of resources without throttling. If I want to go and fix one of these issues, it's easy to go in vulnerability using the taint flow analysis or data flow on the left to actually step through the code, understanding how I've introduced this SQL injection problem, and then using the fix analysis in order to understand a bit more about it before I go and do this fix. So here we've got some general information about how to prevent this, some best practices which help educate the developer. And over on the right-hand side, we've actually got some examples from good open source projects about how other people have fixed the same or similar problem. So I can scroll through these to decide actually which is going to be the best for me. And then I can actually go to that commit and start looking how other developers have solved a similar problem to me as well. So there you've seen the prioritization, helping with remediation. And then when we talk about education, if you look down at the bottom here, what we can actually do, aside from fixing this vulnerability in the code that I'm addressing, I can also go and take an extra lesson. Now, this extra lesson takes me completely out of my kind of work frame of mind. It allows me to understand from a conceptual basis what an SQL injection error is. It allows me to go down, create some vulnerable code, exploit the vulnerable code, and fix the vulnerable code so it's no longer exploitable. And you'll see more and more of these types of lessons appearing within Snyk, which will help you not just fix the vulnerability you've got now, but prevent those in the future. And that was a quick little intro into the open source code, the source code or developer written source code. Now let's go and have a look at the report for the open source code. And here what we're doing is we're finding the manifest files. So in this case, it's a package.json. It could be a pom.xml. It could be a Gradle file. Again, whichever languages you're using, we're using the manifest files in order to find those dependencies. And what we do is we build a report similar. Again, it's all about prioritization, remediation, and education. Here you see in the top vulnerability, it's giving me my Snyk score, telling me where it was introduced, 04. Now, what we're actually doing here is building a full dependency tree for this whole application. So we can understand when you've got vulnerabilities at the top level, and if you've got vulnerabilities further down those leaves or branches as well. And we always give you the remediation advice in terms of the top level. Just an example of this, if I go to my dependency tree, and if I click on this tree view, you can see that we've got some vulnerabilities here. Here's one: body parser itself does not have a vulnerability. But if I open this up its transitive dependencies do, and one called QS as a high. Now, in order to fix that QS problem, actually, I need to upgrade body parser. That's just how NPM works. There's no pinning or hoisting. So what I need to do is understand in the context of body parser, how do I remove the QS problem? And Snyk actually does all of that work for you. So if I go and look for this QS problem, you'll see now that we have grouped together actually 3 vulnerable instances of QS, and we've told you how to fix 2 of them by upgrading Express and upgrading body parser. But one of them's not upgradable because TAP themselves haven't created an upgrade to that package. But at least you know you've got the problem. You can decide what to do next. Should I, as a developer, go and help TAP by creating then a new version with the unvulnerable QS? Should I contribute back to open source? Should I fork this project myself? Should I use a different open source package? But all those options are available to you now that you understand what's going on. But down at the bottom, I can go and partially fix this, which will fix the 2 that are immediately fixable. And then I can go and address the other one later on. Now, if I go and click on this, first I'm going to go to an interim screen, which just has the items that I wanted to fix selected, which you'll see down at the bottom here. And if I go and open that pull request, this integration is actually with, let me see where this integration is from. This may be a GitHub one, but it's very similar for all the SCMs anyway. And what we're doing is we're creating that pull request, updating the package.json, and we're updating the lock file as well, and allowing the developers to see what's going on. We're also running some Delta checks on that pull request. And that means that the license and security checks for that pull request make sure we're adding no new vulnerabilities as well. Okay, so now we've looked at the source code that the developers write in. We've looked at the open source. Imagine now our app is fully complete. Our next stage is to look at the open source, the container that the app gets deployed upon. And this is where Shai is going to give us a quick example of how you can use the Docker capabilities to find the vulnerabilities on those packages. Shai, do you want me to stop sharing and you can share?
Yep, that sounds great.
Excellent, thank you. There we go.
Ooh. Not that screen, this screen. Okay, is that, oop. Sorry, I'm getting permission stuff. Give me 1 second. There we go. Is that coming through okay?
I'm seeing kind of half. The screen is
Half
half, but I can.
My terminal isn't coming through? It's.
I can't see your terminal now.
Oh no, I think I need to quit and rejoin. I just got the OS X permissions thing, so I will be back in just 1 second. Sorry about that, everyone.
No problem. Amir, can you take the guitar off the wall and give us a quick tune while we're waiting for Shai? Oh, you're on mute.
So I would love to. I'm not sure the audience would love that, but
no problem. Let's just give him 30 seconds and see if we can get on there then.
Exactly.
No problem. I could always actually go and show something if I can just reshare my screen while we're waiting.
And just while we're waiting, I think sometimes you were cut off, Paul. So I wonder if you shouldn't turn off your camera.
Okay,
afterwards,
I will do.
Maybe because it was sometimes a little bit cutting off.
I'll turn off the camera then. Yep, thank you. Cheers, Amir.
All right. Seeing everything this time?
Yes.
Yes, we are. Yes, we are.
Brilliant. Sorry about that, everyone. Okay, so let's get started. So we're using this Goof application that the folks over at Snyk have put together, and it's full of already existing vulnerabilities. Paul was just showing us some of them in the demo that he was doing earlier. So I'm going to go ahead and take this application and I'm going to containerize it. So I already have it running on my, or I already have it downloaded on my system. We've got a Docker file here already. So let's go ahead and just take a quick peek of what's going on there. So we can see right away that we're using Node, and we're doing something good in that we're already using the official version of Node. So one of the nice things about Docker is that we've got all these different images that we can choose from. And here we're using an official one. It's published and it's verified on our end. And I think that's just an easy thing you can do to kind of make sure you're staying secure, is using the official images when you have the opportunity. And, you know, it's got the little tick on there. And then we're kind of just doing the standard stuff. You know, we're building the application, we're copying it inside the container, we're running our updates, we're exposing some ports, and then we're starting it. So I'm going to go ahead and just build this application really quickly. And that's just going to be a Docker build. And then I'm going to name it. And I'm going to name it Shy Ruparel, which is my Docker name. And then goof image. And I will set it as latest. And I want to build everything here. So here we go. It's building. And that was really quick because I've already built it and I haven't changed anything. So now if I open up Docker Desktop and go and take a look at my images section, I can see that goof is right here. And if I refresh that, yeah, so it's right here, and I can go ahead and I can push it over to Docker Hub. And this will take just a second. And now if I go over to Docker Hub and look at my profile, we can see I've got goof here, and we've got some vulnerabilities showing up. So this is something I had to actually turn on. So I can head into my settings, and there's this vulnerability scanning option. I enabled it before the demo because it does take a couple minutes to run once you have it. And I didn't think anyone would want to sit and wait for the thing to run. But there we have it. We can see the list of vulnerabilities. And I can also run this locally using the command line if I want. So I'm going to head over to the Docker documentation and pull up the docs so we can see it's Docker scan and then the image name. So let's go ahead and get started. Scan and then Shy Ruparel, goof, image, latest. And it'll go ahead and start running that locally on my machine as well. And so I can start diving in and mediating some of these vulnerabilities as I find them. And we can, see all of them here kind of listed by severity as well. So yeah, that's kind of how Snyk integrates into Docker. You can grab it from the hub, you can grab it locally on the command line. And I think it's really great. And now that we've found all of these problems, I think we can hand it back to Paul to maybe talk about fixing some of them. If that works for you, Paul? I feel like I'm just handing you extra work here. Like I've just caused you a bunch of problems.
I love fixing vulnerabilities. It's my job. Don't you worry.
All right.
Okay. Right. Let me share the screen then for a second, because we've got actually two ways we can start looking at Docker containers in order to fix them. So at Snyk, what you can do is you can look at the Docker file before you've even created an image. And that's great because, if we're talking about shifting left, if we can find the vulnerabilities before we've bothered to build the image, even better. So I can go here and look at my Docker file. And what Snyk does, it looks at perhaps what that container would look like should it have been built. And here we've got information that shows things like, this is my current image, node 1410. And it's got 958 vulnerabilities. An absolute dog's dinner. So you do not want to use that image at all. But what we can do is we can say, actually, there are some alternatives. Now, you do, as a developer, need to understand these alternatives in the context of the app you are building. You need to determine whether or not this would be a sufficient upgrade. But we are giving you this information, and this information is updated every day. Now, if you were to try and do an audit yourself of the possible images that you could use for a base image out there, it could take you a couple of hours work to do. And you certainly don't want to do this for all the applications every day. So this is really a time-saving device. And I can go and look at these and decide, right, let me try this one then. This looks like it will work. And I can go and open at pull request. And then that will go over to the SCM tool integrated and allow us to update that container. Then, obviously, things like your automated build would kick off, and that would determine whether or not your tests would pass on that as well. Okay, so what we've done is we've looked at really the three parts of this, of the modern application stack: the code, the open source, the container. Now let's look at the actual infrastructure as code. So usually when we get these containers, they're then going to be deployed in a Kubernetes cluster. So what I've actually done, I've deployed a similar application over on Amazon EKS. And you can see here just my Amazon EKS here is my application that I'm looking at. And what I've done on the workloads is I've deployed the Snyk monitor. And the Snyk monitor kind of sits on there and understands what's running on the application and can give me some insight into what's happening there and are there any vulnerabilities. So once I've connected it, then that appears on the Snyk UI. So if I go back into my projects now, you'll see it will have connected the cluster. And if I go into that cluster now, what we're doing is we're saying, in fact, let me just reconnect that because I've connected to the Snyk monitor, but not the actual application. So I want to connect to my default and add that workload. So what I was using, the Snyk monitor to look at the Snyk monitor. So obviously everything's going to be okay there. But now what we're doing, we're looking at the actual workload. So you can see it's just pulled it in there now. And what we're saying is there is a Debian image working on there. But what I want to do is look at actually how that cluster's set up. And here you can see on the right-hand side, we're running some tests on that Amazon EKS cluster. What am I doing with the containers on there? Has it passed or failed some of the tests? And you can see here, actually, it's running as non-root, so that's failed. The read-only file system and drop capabilities, it's failed 3 of those tests because I've not set that cluster up correctly. And then down at the bottom, again, you're seeing that prioritized list of the vulnerabilities on the containers that are running on that cluster as well. So that gives you an idea as to what's going on with that cluster. But again, you might say, what can we do to shift that left? Well, I can actually go and look, if I go back to this cluster, at the infrastructure as code files that send this cluster live. And I can say, for instance, here's my cloud formation script or my deployment.yaml. I can go into those and before I've even deployed the cluster, detect whether it will have any vulnerabilities according to the profile that my risk team have set. So here you can see we've got a number of issues, but again, Snyk's all about education. How do I prevent these things in future? So we give you the issue, the impact, and how it can be resolved. And here you can usually take what Snyk gives you, go and add that at or below line 2 here in order to actually add these items and go and fix the infrastructure as code for you. And again, if you feel this is not important, you can go and change your policy so that you're only highlighting things that actually happen. So imagine we've got everything nice and clean and clear now. And what we want to do is have some automated tools in that step in order to do these tests. So what we can actually do in code pipeline, we can actually have tests that look at the SAST scan. We can have tests that do the open source, the container, or the infrastructure as code scans as well. And if you look at this stylized kind of pipeline that I've built here, obviously very simple, wouldn't be used in production, but I've introduced a Snyk scan in the middle. And what we can do with Snyk scan, we can do 2 things. Either create a report, which is good, but we can also fail builds based off certain types of vulnerabilities. So again, in terms of automating the sending live, the continuous deployment of applications, we want to be able to make decisions based off these outputs for these scans. So if I want to go and look at this, I can actually go and look at the report. It will tell me the problems. Oops, they have expired, unfortunately. But what I did do before this was I went here and I've actually added the project you'll see from Code Pipeline, because I can also push any project that goes through Code Pipeline into my report. And you can see it's found the same app that's running through that application, and it's given me the open source vulnerabilities that have been found on that application as well. And again, I can go through and try and find those vulnerabilities. Now, when we're talking about deploying on AWS, we're talking about using ECS and EKS. I wonder if you, Amir, could perhaps give us a bit of a highlight into the different deployment mechanisms on Amazon and help us understand what we can do there.
Yeah, sure. Thank you, Paul. Yeah, so as Paul said, we have several ways of deploying your applications on Amazon. And today we're more constantly really focusing on the container side and the serverless side, I would say. So first of all, we have two main services to run containers. So historically, we had the Elastic Container Service, ECS, which is our own opinionated way to manage a cluster. And the idea with ECS is really the use case is if you really want to deploy easily and rapidly a cluster, ECS is really a good choice. But we also introduced, of course, EKS to run a Kubernetes cluster. So it's a managed cluster. It means that basically you're not going to take care of deploying the control nodes, right? We take care of that. We deploy a control node with resiliency in mind, and you just then need to take care of your workers here. And so EKS is really a good choice if you want more, I would say, flexibility to your cluster and want to make use of the vibrant ecosystem of Kubernetes. So basically, both choices are available for you. And for each choice, you again have several choices behind. So either you run them normally, it means that you need to manage the underlying worker nodes, so on VMs, on EC2 instances. So that's good for people who really want to really have the upper hand on the underlying underlying instances, right? But if that's not what you want, we also have a mode called Fargate. Fargate basically abstracts away the VM and allows you just to go and deploy your containers, and we will then scale the infrastructure behind the scene for you and manage the infrastructure for you. So one advantage, if we talk about security, because today the focus is on security, is that, as you might know, we have something called the shared responsibility model at AWS. It means that we say that AWS is responsible of the security of the cloud, and the customer is responsible of the security in the cloud. So what do I mean? It means that we are responsible, of course, the data centers. We are responsible of making them secure physically, the firmwares, all the way up to the VM. It's our responsibility to make it secure. So if you deploy your own VM EC2 on AWS, at that point you would be responsible of what's going on in that VM. So if you don't use Fargate, you would be then responsible of patching and upgrading those underlying resources, right? However, if you go with Fargate, then this brings the responsibility on our side. It means that it's up to us, since the virtual machine is completely abstracted away from you. The responsibility is on us to make sure that the underlying OS is patched, is secured. So this is something to keep in mind. It's not just for ease of use. It's also a security posture. Is that you rely more on us for the security of the underlying infrastructure. Then we also have AWS Lambda. We just put it here. We're not going to go too much into detail. That's really the function as a service feature from AWS, where you can just create a function and run it. However, we put it there because we also announced some time ago that you can also deploy a container within your Lambda. I'm just saying that. I don't want to go too much into the details of that, because then it would take us very far. Just that you know that exists. And finally, we have the ECR, which is our image registry, which allows you to host your images privately or publicly within AWS. So can you go to the next slide, please, Paul?
Yes.
So here I'm just going to focus on EKS, but the same thing for ECS. So one advantage actually of using EKS is that on AWS, that it somehow blends in nicely with all the other kind of services that come with AWS. So if you talk about security, so it's integrated with IAM, with KMS if you want to do your encryptions. It's integrated with our storage, different storage services and networking storages. So basically, it's interesting to see that we have already baked that in for you. So that's one of the big advantages of running EKS on AWS. So next slide, please. Nope. Yes. And just again, it's not. I don't want to go too deep in it, but just for you to know that it exists. So EKS is, as I told you, the managed Kubernetes service on AWS. However, at AWS, we really listen to our customers. As you know, more than 95% of our roadmap is actually from customer demands. And for several use cases, we have been asked, customers need to deploy their clusters on premises, on their own hardware. So it could be for regulatory reasons, for data location problems, for or just that customer had invested in some hardware that still needs to be used for a couple of years, and they still need to deploy the clusters there. So apart from EKS running on AWS, we have announced different options for that. So one is that you can run your EKS on Outposts. So Outpost is a rack that we bring to your own data center. So think of it as an extension of your AWS region within your own data center. So it has the same hardware, the same control plane. You go through the console. It's just that if you want to deploy on Outpost, basically what you do is that you create just a new subnet, and the subnet is located on an Outpost, and anything you deploy on that subnet will end up being in your data center. We also have local zones, which are zones that are not full-fledged regions. These are compute resources that we place near can be nearer to your facility. So this is interesting if you really want to have a lower latency, if you're a little bit far from a nearest region. And finally, we introduced EKS Anywhere. It means that basically you can take EKS, the same product that we are using at AWS, and it is open source, and you can take it and run it in your own data center. And it can be integrated then also with your console in AKS to have everything consolidated. But again, I don't want to go too much far into this topic, but just to let you know that all these possibilities exist for you. And EKS distro is basically the distribution that we are using at Amazon that will be used by EKS Anywhere to deploy your Kubernetes clusters on premises. So next slide, please. So today, again, since the main topic is security, I wanted to introduce. So we have many security services, as you know, but I wanted to just focus on Amazon Inspector, which is an interesting use case here because for two reasons. First of all, why do we call it the new Amazon Inspector? Because Amazon Inspector has been around for some time, but we actually completely revamped it and introduced this in the last reInvent back in December, sorry. And actually, Inspector is an automated vulnerability management service. And the new Inspector continually scans your workload for software vulnerabilities in near real time. What do I mean near real time? So previously in Inspector, first of all you had to deploy an agent, a specific agent, an Inspector agent on each of your VMs or compute nodes. And you had to maybe schedule or run manually your assessments. So people used to schedule once a day, scan their environment to see if there are any vulnerabilities. So with the new Inspector, what happens? First of all, we're just using the commonly used Amazon SSM agent that many customers already use, that are installed. For example, if you're using AWS Amazon Linux or Windows on AWS, the agents are automatically installed and already there. And so first of all, the new Inspector doesn't need a separate agent. And most importantly, what it does is that it's not that it's continuously scanning your environment. It's just waiting for events. So for example, if something changes in your environment, it will rescan it again. Or if a new CVE arrives in the database, then it will also get triggered and rescan your environment. So you can get basically vulnerabilities in almost near real time. And this works as well with EC2 as well as with your Docker images that are in ECR. So next slide, please. So Amazon Inspector, we announced that we have a partnership with Snyk. Basically, this means that you can we get the access to the Snyk security vulnerability database within Inspector. It means that it will use Snyk's technology to also detect vulnerabilities within Inspector. And one last thing I really want to emphasize here is that in the cloud, what the cloud is extremely great for many things, but one thing that is dear to my heart is automation. Automation of everything. So of course, automation of your infrastructure. We talked about infrastructure as code, but mainly also automation of remediation of any problem. So what I want to say here is that with Inspector, let's say that, as I told you, in near real time, you can get any vulnerabilities that are detected. So let's say you get a new high risk vulnerability that is reported by Inspector at 3 in the morning. So we don't want to wake up your people, your staff, your ops, or your DevOps guys at night. So what you can do with Amazon, and what we recommend to do, is to automate as much as possible the remediation. So for example, in this case, Inspector can shoot an event using Amazon Event Bridge or going through Security Hub. And Amazon Event Bridge, in turn, can go on and shoot a Lambda function that can then inspect what's the vulnerability, and can take actions automatically without even waking your staff up whenever possible, right? But we can also fan this out and also send, for example, an email, or even send an SMS message using SNS. So I always want to emphasize that it's great to catch vulnerabilities. It's even better to automate the resolution.
So just to ask a question on that, Amit. So Amazon Inspector, once it's received a new CVE, detected that that CVE exists in one or more of your containers, will then generate outbound events that you can catch in Event Bridge to do actual actions.
Exactly.
Fantastic.
Exactly.
Very good. Very good. I might have to make some of those myself.
I highly recommended it, Paul.
Yes, I will. I'll give that a go.
And with that, I think that was my last slide, if I'm not wrong.
I think so, yes. And what I was just going to show you is actually, you did mention that Snyk is now a data source inside Amazon Inspector. So I've just got a very simple dashboard just to kind of show you what's going on here. And that dashboard just gives me, how many repositories or instances of containers that I've got, the critical findings that we've found, whether it's in the container, the EC2, and we've also got a list of these vulnerabilities as well, whether they're critical, medium, low, or high. Here, I'm just looking at the critical. If I want to drill down into individual vulnerabilities, what I can do is I can go and look at the different repositories which we're scanning. I can choose one of those repositories and look at the container images in this case, which will give me an idea of what exists there and the number of vulnerabilities. And then clicking on that tag, whichever one I have, I can go and look at the individual vulnerabilities. Now, what this is, these are not all Snyk vulnerabilities. Snyk is one of the data sources that adds to the Amazon Inspector. It's a very good service. But what we can do, we can go into these individual vulnerabilities and we can see, actually, yeah, this is the information down here. Where can I go in order to fix that as well? And this one actually comes from the Snyk database. So what we can use that Amazon Inspector to do, rather than just looking at these vulnerabilities, as Amir is saying, is we can actually start triggering outbound events, which is the next thing I'm going to go and try and do in this integration with Snyk and AWS, to try and get some outbound events, either for notifications or perhaps even try and block a port on a WAF because of a certain vulnerability, things like that. Let's see what we can do in that space. Okay. I believe we're coming up on time now, so I just wanted to perhaps give a quick 5-minute overview of what we've achieved today by way of just looking at one slide. So we've looked really at what a modern cloud application is, how that is how it is built up, that's better, from code, open source, containers, and infrastructure as code, and how we can look at all of those different layers to find vulnerabilities, fix the vulnerabilities, educate the developers, and ensure compliance across infrastructure as it goes to the cloud. How we can integrate at different parts of the AWS pipeline with code commit, code pipeline, inspector, ECS, EKS, and then over into the live clusters as well. And how, when we're building those containers, we can use the Docker tools to make sure we're building the most secure container from the start as well. And Shai showed you how to do all of that there. If there are any questions, please add them into the Q&A now, and we will attempt to answer them. I'm just going to have a look at that to see if anything's in there. Oh, there was one. It's been answered. Fantastic. let me just put up the last slide then and say thank you for attending today. Obviously, either of us, any of us on the call are available for follow-up. If you have any questions, want to dig deeper into any of the situations or technologies that we've mentioned today, please come and give us a shout, an email or a call. We're all available to have them conversations. So thank you very much for attending today. Cheers.
Thank you very much.
Thanks, everyone.
Well, I'd like to thank Paul, Shai, and Amir for taking the time to be with us today and putting together these demos and the slide deck and just sharing their expertise with us. So I really appreciate each of you being here with me today.
Our pleasure.
Yeah, thank you for having us.
And I would like to remind our audience that today's session was recorded. Following this webinar, you'll receive an email with a link to access the recording on demand. You can also find the recording living on the Container Journal website if you just visit containerjournal.com/webinars and look in the on-demand section. So quickly, we do have 4 winners for $25 Amazon gift cards. Our first winner is Alyssa S. Our second winner is Roshan D. Our third winner is Antonio F. And our fourth winner is Alexander M. So congratulations. Keep an eye on your inbox to claim that gift card. And if you don't see an email, just check your spam folder. I would like to extend our gratitude to Snyk for sponsoring today's webinar. And my final thanks goes to you, our audience. We appreciate you being here with us today. Please take a moment to fill out our post-webinar survey, and we hope to see you at a future TechStrong Learning webinar. This is Cody J. Brown signing off.
Cheers, everyone. Bye.